Okay, class, this is the motion second part that I have promised you that I'll make the second part for the equation of motion. That is the most important part for your ninth class. That is equation equations of motion. So I will say that is three equations which you have to derive. That is, first equation is v is equals to u plus at. Second is s is equals to ut plus half at square, and third one is 2as is equals to v square minus u square. You all know the variables in this topic. That is, v is the your final velocity, u is the initial, a is the acceleration, time is the t is time, and su, I think you know that the distance or displacement. Distance, or generally we take it as a displacement. So you have to draw these three derivation. You have to do, I think in ninth class you are doing it this first time, the derivation part. So we will consider, so derivation equation of motion by a graphical method. Graphical method, that is, I am considering a body. This is the velocity time graph which we discussed in the previous video. Velocity time graph, this is velocity meter per second. Units you always have to write down, and this is time in seconds. I'm taking a velocity time graph which is considering in a uniform motion. I'm taking here's an object at origin. It travels here at point A with the initial uniform velocity u. It accelerates and it changes its velocity to here. This is the your total, this point is v, and this is total t. If you considering this whole part, this axis is total t, and this whole axis is total v. So it increases velocity to final. That final here would be v, and you can say that this is the velocity time graph. I'm just joining these things. For example, if I join this like this and this and this, I'm joining this part. So hence its total is v. This is u because graph is parallel like this. So it would be v, and this small one is v. So I hope so you will understand that this would be v minus u. Like simple, if I say this is a whole line and this whole length of a line is 10 and this is 2, so how much would be this part? This part would be 8, that is 10 minus 2. Similarly, it is total is v and this is u, so it would be v minus u. I'm considering the point. This is a, b, c and d, and this is the o. So a body is traveling with the uniform velocity u, and it ends up with the, here it is the final velocity is v, and this small bc is v minus u. So, and this is total is the z, and if this is t, and you can say that this total is t, this is t, so it would be also t. I'll show in the figure. So for example, first of all I'll say that what will be the change of velocity. If I said change of velocity, the velocity changes its value. Initially it was u, and finally it was at this point. At this point velocity is this, and this is nothing but v. I can say that the velocity acceleration, yeah, we can say that rate of change of velocity, rate of change of velocity would be rate of change. I always tell you the rate, that means you have to divide it by the time. So rate of change of velocity is called acceleration, and velocity is changing, that is u to final v, that is v minus u in time period, that is t. So that would be a is equals to v, that is you all know that is the acceleration part that I have told you in the previous video, that is acceleration is equals to v minus u by 2. The acceleration is change in velocity by time taken. Similarly you can say that from in another sentence or in another words, acceleration is change in velocity. Velocity कितनी change हुई है? v minus u. Initially u थी, finally कितनी हो गई यहाँ से लेके यहाँ तक? v. So v minus u by t. When you cross multiply this would be 80 is equals to v minus u, or you can say that v is equals to u plus 8. So mark it equation number 1, but we have derived our first equation, that is v is equals to u plus 80, this one. But I'll make use of this part in another video, another equation. So that would be, we have to consider it this. I'll by the time I will consider again the graph. So in second part you can say that in second part I'll take this graph. If I, for example, one thing that I have left is that if I'm calculating the velocity time graph, this is time and this is velocity. Velocity into time, velocity into time, or you all know equal to displacement. So velocity time graph would be equal to give you displacement and area under the graph, like this velocity time graph, and this is like this. You can say that let me take another example. For example, if I tell that here is a point, this is question. Try to understand this velocity meter per second. If I say that there is a figure like this, uh, like this. Okay. This is 0, this is 5, and this is 5 and this is 10. So if I tell that find the displacement, you will say that displacement would be velocity in time, that means this part, area of figure, that is, if I left this part, so it is a triangle, and triangle का area क्या होता है, half into base into height. In this case half into base, यहाँ से लेके यहाँ तक कितना है 5, and height, this thing, this is 10. So area displacement would be 25 meters. So area under graph always give you displacement. Let us one more example. For example, if I say that, for example, if I, this is a this thing, this 2, 4, 6, and 8. Let me say this is a square. This is velocity meter per second, time in second only, 0, 2, 4, 6, and 8. Like this is a square. This is 8, this is 8, so obviously this is the 8 and this is 8. I said find the displacement. So displacement would be area under this graph. Area under this graph is this much. So area displacement would be velocity into time, and velocity into time, and we can say that velocity time is the multiplication of this part. Area under, sorry, I'll just write it down again. Area under the graph, so it would be, since it is a square, so obviously 8 square ka area, side square, that would be 8 into 8. So the velocity area under graph would be give you displacement, and 8 into 8 is 64 meter. I hope you get it. The area under graph always give you displacement. So let us consider the second equation. I hope you understand that. Area under graph, I can say that area under graph, that is velocity into time, and it would give us displacement. S is equals to area. Let's consider this figure again. I hope you can figure this thing. It is, area is like in two parts. First of all, if I consider like this, it is a trapezium. This side and this side, two parallel sides, and this is a perpendicular height of the trapezium. We will do it in third part, but in that case, it is like this. If you see this part and this part, you can say that this is the triangle and this is a rectangle. We can say that you can, if you want to find the area of figure, you will get the area of triangle plus area of rectangle. See here, this area of triangle and this area of rectangle, you will get the displacement. So how will you find this? How will you find that? That area under, that would be area of triangle plus area of rectangle. You can say that area of triangle, in the triangle is A, B, and C, plus area of rectangle, see it again, O, A, C, D. That would be your area, this area, graph के अंदर, है ना? So it would be, rectangle is O, A, C, D, and triangle, that you all know, triangle has an area that is half into base into height, and rectangle has area length into breadth. here it is considering area under graph हमें देता क्या है displacement जो हमने पहले भी मैंने बता चुका हूँ इस चीज़ को half into base OD sorry AC into BC plus length into breadth. Length would be OA and breadth would be OD. Like you can see it from here. This is your triangle. Base. This is base and this is height. Base is AC and height is BC. And rectangle. This is I have taken this as breadth and this is length. OA. This OA into OD would be your length into breadth. So it would be half into AC. A into C. You can see it from here. AC. AC is nothing but time because it's rectangles. If I'm considering it a rectangle, rectangles is opposite side equal. So if it is U, it is U. If this part is T, it would be also T. So it would be half into T into BC. BC you can see here. BC is this is V and this is U and BC is V minus U. So it would be V minus U plus O in A into OD. OA. OA is U into OD. O से लेके D कितना है T. ठीक है. So it would be T and this is S. You can say that S is equals to half into T, but V minus U I can from equation 1 which we have proved this one. I've told you I will use this thing. V minus U is 80. V minus U is 80. So it would be 80. I can write it like here. From 1 V minus U is equals to 80. So it would be half 80 square plus UT, and this is your second equation of motion. You can say that this is equal to you have to rearrange it UT plus half 80 square. प्लस हैं तो जैसे मर्जी लिखो UT plus half 80 square. So this is your second equation of motion. S is equals to UT plus half 80 square. That is the second equation of motion. So next your third one, that is now we will find the same area but we'll consider as a trapezium. If you see this figure again like this, I will draw it for you. This and this and this, and here this is perpendicular, right? This is V minus U, this is U, and this whole is V. This is U, this is time, and this is also time. If you can see this figure, this is nothing but this is a trapezium, but it is a velocity time graph. So the graph is like this, U and this. So this is velocity time graph, this is V and this is your T. So we know that velocity time graph अगर हम multiply करते हैं तो we'll get the displacement. So trapezium area, area of trapezium area will give us displacement, and area of trapezium half into sum of parallel side into height. So it would be S is equals to half into sum of parallel sides. Parallel side, that means this whole V and U. I'll be getting parallel side, this and this. So it would be V plus U total from here to here, that is V into height would be this perpendicular height, and this perpendicular height is nothing but T. So you can say that half into sum of parallel side into this. So V plus U, and from here we can say that again using 1 1 from 1 we have 80 is equals to V minus U. 80 is equals to V minus U. You can say that time would be V minus U by A. I'll put this value here. Time would be V minus U by A. So therefore S is equals to half into U plus V, or you can say that, sorry, V plus U, so that would be, doesn't matter, V minus U by A. This 2 into A multiply, cross multiply here, and you can say that A plus B and A minus B. A square minus B square, you know that? I hope you know that identity. A square minus B square, so it would be v square minus u square, and that is your third equation of motion. That is 2as is equals to v square minus u square. So I hope you understand this thing, and I'm promising you I'll give it into your periodic. So please learn it. I'll give it in periodic, and in your final or in any equation you will get the equations of motion, and it is important for the +1 part also. So do this thing in your fair notebook, and in next video I will consider the numericals. So I hope you understand this video. Thank you.